I'm really happy to be here. I'm talking about a subject that a lot of us think is the most exciting thing, certainly since sliced bread, and we just love it. I mean, we work in it and work hard, but because it's very exciting. And what I'm trying to give you is an idea of the potential of the field. So first, I'll talk about AI, and sort of at a low level, just to show you how wide it is. And then I'll talk about the research that I do, which we call precision education. In other words, identifying what a student needs and refining the comments or the hints and what have you, so for that particular student. So it's really like precision medicine. It's not one size fits all. Okay, so to just clarify where we are, there's computer science, you've heard of that, and that has 3 branches. Artificial intelligence is one, software engineering is one, and the third one is theoretical computing. And then there are AI subtopics. So we're going to look at machine learning, and your second talk today is on machine learning. There's natural language, there's planning, there's robotics. These are subtopics, hot portions of AI. I'm happy to give my slides to people so you don't have to copy them if you want to arrange them. Yeah. And then after subtopics, we look at applications. So there's a lot of fields that have been developed, like automatic cars and recommendation systems and ChatGPT, etc. These are now applications that they seem to have a life of their own and they're moving on, but they're not AI subtopics. Okay. So if you have questions, just let me know. So I'm looking first at AI in the press, and we will not talk about this because these are heavy, heavy topics. But 350 AI leaders are scared of AI, according to the New York Times. China spends $200 billion on surveillance. You've heard about that. I mean, you're librarians, you keep up with these things. 2/3 of Americans believe generative AI possesses a threat to humanity, Harris poll. 4/5 of Americans agree that a bad actor can use AI to do harm. And AI may be the atomic bomb of the 21st century. You guys read the newspapers, this is all over. So I'm not going to talk about it. But to say that the dangers are already here. There are already biased systems. That is, the database has people in it which will bias the database so that when the AI makes a decision, it's already looking at the biased set of people. You know about that. Disinformation is already here. Job loss is just beginning. Subjugation, educational inequality and attainment, so you know about that. But to look at the AI in perspective, industrial revolutions, this is grossly oversimplified, but you know we have mechanical power happened, electric power, now computer power, but AI power is going to surpass them all. Computer perception, autonomous robots, all those applications that we talked about are coming online, and it should be bigger than all these others. So the impact on AI, why should you know anything about AI? And I say it's the new electricity. Students are growing up with AI. Children in kindergarten have already used Alexa for years. And autonomous robots are going to be everywhere. So I'm going to give you some definitions. Just AI is the intelligence. It's perceiving and synthesizing and inferring information. And it's demonstrating that by machines as opposed to by humans. So everything we think we can do, can we get machines to do? That's kind of the objective of AI. And that starts with seeing, perception, seeing and hearing and talking, and summarizing even, and reading. And it goes on to, of course, moving, embodied systems and robotics and all that good stuff. And then algorithm. Does anyone know what an algorithm is? Yeah.
So I should fully disclose that I have a comp sci background and have worked on systems like this. Cool. So so it's a mathematical model for making decisions, and there are different ways in which they're constructed. So yes.
But more simply, it's just a recipe.
Yeah.
I mean, it's a model, but it just has a bunch of rules, step-by-step procedures for doing a calculation. You can get algorithms in every area, but just think of it as a vanilla cupcake. First you light the flame, and then you use a muffin tin, and then blah, blah, blah. It's just a bunch of rules. Okay? So the impact on librarians is that AI has the ability to do context indexing. You could put in 50 documents and say, summarize all these, or index all these, and which ones talk about the same 2 topics. Document matching. Let's see. Yeah. AI machines can process documents faster and more accurately than can humans. And I mean, the game plan for most of AI is to remove from humans this repetitive stuff. Does anyone really want to do document matching? And wouldn't you have more exciting things to do if you had a little machine beside you and you just poured in these documents or let it see the writing on the door, on a shelf, and let the machine do some of this organizing for you? And some claim that there will be depth of citation because
Please do.
because AI, will just automatically go in and you'll say a person's name or a number, and it will be in a big database, and everybody will use the same database, and it'll attach it. And summarization is already being done nicely. AI can just read documents and summarize them. And quality of service can improve the quality. So it should have a wonderful impact on librarians. I mean, if you think you have any pattern-based and repetitive work that you do that you'd like to get rid of, this is the field. So will it answer, will answer simple information questions. It will influence the way information can be connected. There are visualization tools, and I'll be showing you a few. And it will be able to analyze digital collections, identify topics, etc. So you probably know about that. So people have said, and the hype right now is that large language models is the answer, but they're not really the answer yet. In part because they can't provide, I say medical information, but they can't provide reliable information. In fact, they can't provide any information. It seems to be confusing from the way the press is suggesting, but AI large language models don't know anything. They don't reason about anything. They're just taking words and putting them in syntax and semantics together and giving you paragraphs. And people love having those paragraphs, but you can't go into that system and ask it any questions or get it to move any beyond. It can't do attribution to cite existing things. It can't understand what's relevant to what you're saying. So right now, we need information collections to help LLMs. And at the flip side, LLMs can make collections, clinical trials, for instance, more digestible structural information, and they can augment reading, etc. All right, so what is AI? I'm going to go just the basics here, starting. And this is material put together by David Turitsky at MIT. And I think it's lovely. It's a large folder. I thought this might be interesting. This is a large poster available in 16 languages that you can just go by going to that site. And it says that these are the 5 big areas, and that people have different areas, but perception, representation, learning, and natural interaction. And that natural interaction has 3 or 4 components. So this is, and social impact actually, the one inside is the biggest. So you can say that's what AI is, and you'd be pretty fine about it. And okay, so looking at perception. Computers perceive the world. They use senses. They can use sight and can talk, can see things, can speak, can talk, and they use algorithms to perceive. For instance, that picture. It can identify each of these fellows in terms of height, perhaps in terms of breadth. I can't do much more, but so all the senses on computers and robots can do a lot to see. Let me draw an object for it to recognize. So let me go back. Okay, quick draw. Let's draw. So I'm going to draw a picture. All right. Where would I go? I just did. You just need to left click. Sorry. Okay, got it. Where's left click?
So you're in it.
You're in it.
I'm in it now. What we're going to draw. Okay, what is this? And it's going to try to guess.
I see a magic wand.
What is
diamond? Arrow.
a lightning? See, it's saying, okay, it's doing the same thing you're doing. And it was not me, actually. Got it. I'll try a better picture. I'm just having. Okay, like that, and like that, and like that. Did you see it's light bulb? Ice cream, this is what I thought it was. Okay, so do you detect the difference between visualizing what I did, but analyzing what I did?
Yes.
Okay, so that's, and it's now telling me to draw a prism. I don't know what that draw a prism. Anyway, you're seeing that it's understanding what I'm doing as opposed to just looking at it. Can you advise how to get out of here then?
Yeah, up at the top.
Excellent. Okay. Good witch. I changed the machine somewhere in the middle.
Or just close that part of your browser.
I Oh, X. Okay.
Yeah, just the tab. Just the tab.
Where it says quick draw?
Yeah, just close that.
Got it, quick draw. Got it.
Yeah.
Thank you. Okay, so that's what we did. We just demonstrated that it can visualize and it can interpret. And trying to tell you what it's doing, it's looking, for instance, if it's going to find an A, it's going to look at the top piece of an A, the square, the part that has a horizontal line going through it on the left, the part that has it on the right, then it's going to put all those together, and it's going to detect that you have an A, so it can detect symbols. And then we're going to try to talk to it. Yeah, so.
This is a Mac versus PC.
Yeah, nonsense, yeah.
Let me show you where to click.
Oh, and
I'm not supported by this browser. Okay, let me see, can you talk into that?
It says, oh, right. So,
So, hello, this is Librarians talking. Click here for experiment to try. Okay. So,
Unmute. It's still muted. Click on it and then click the X.
sorry.
Yeah, there we go.
Here?
click here for experiment, right?
Well, it
No, I
said it
think you have to
wouldn't
hit
work. It
mute.
said it wouldn't work in Firefox.
You're in Firefox. Okay. Got it, let's go to the next.
we could just speak into our phones.
Yeah. Sure. No, it's not, she's right.
We can just speak in our phones.
You've been speaking on the phone for 5 years, right?
Okay, all right.
So let's just go to the,
Or just imagine you're saying, Alexa.
and let's do face demo.
Yeah, the touchpad is different.
I know.
What?
Oh,
Oh,
you have
no,
to
you
use
do
the
allow.
camera.
Oh, sorry.
So where is it?
Face demo, allow.
Okay, so do we have to, let's just stay here. Okay, so the question is, can it see my eyes and notice my face? And the answer is yes. Yeah. Let's see if it's doing that. Okay, here it's actually starting. It's starting to figure out where my eyes are, my nose, my mouth, and it's putting it over here. And it's using machine learning, but we'll talk, in a second talk, we'll talk about that. But anyway, it's doing a green patch detector, and it's edge detection. So it's looking for the edge of my head and the beginning of hair, and it's got the horizontal edge detector here, etc. And you can't tell exactly, but here it's got my mouth. Do you see that? Mm-hmm. And that's a red detector. And it's picking out my eyes, my nose, my mouth, etc. My chin. All right. So again, that you notice the difference between that and just perception. This is actually analyzing. All right. So not to get rid of it, I just go here.
That is so different.
Yeah.
Down here is.
It's the, yeah, we'll go to the next one. Okay, so let's just keep going. So what is computer vision doing? It outlines occluded blocks, objects that differ from the real shape. So it can get edges, it can get changes in color, it can get straightness. Edge detectors can be composed to form more complex features. And the progression from image to meaning is where AI comes in. I mean, AI is also part of the visual part. Takes place in stages with increasingly complex features. So here's an occlusion. If you saw that picture on the left, you see this top picture, how many rectangles would you say there are?
2.
Yeah, 2. Well, yeah. They say none. Because for AI, this is what that picture looks like. It's not reasoning about it.
Yeah.
I mean, that's just the next level. But let me just show you, here's a picture of a different person, and then you have to extract the bounding box. So how is it recognizing the face of this fellow and the chin of this fellow? And here's actually a different fellow, but you see it's doing the same thing it did with me. It's taking that, it's using machine learning, neural net actually, to recognize his chin, his beard, and his eyes. And it's a convolutional layered network, which I'll show you. So what it's doing is recognizing eyes, hair, as long as we all look fairly similar, it's going to be fine. So what about spoken language? Can a system hear you? Yes, but then can it recognize that it's a different word? Well, of course, because you've been talking to Siri for years, right? But you know that. So, but for it to understand speech, it must recognize each of the sounds. And now we're back to here. Let me see if I can put the image in.
Yeah, so on a Mac, you want to press on the right side. On a PC, you want to press on the left side of the mouse
It's
pad.
like.
Oh, press on the corner.
Yeah.
All right. All right, so what you do is you talk, and then you get what you've seen before maybe as a sinus wave and sound system. But then you have to clarify it, parse it into all the items that we just did for vision. Same thing we did for vision, which is to get a different layer to see the outside and to see the edge. So you do the same thing with sounds. With phone, you put sounds in and phonemes come out, phonemes being the parts of words. And I will show you a demo of that later. Okay, so that was the big idea one, which is we can perceive, these systems can perceive, and then they can analyze what they're doing. This big idea number two is representation and reasoning. So it doesn't work to just see that thing. You have to start reasoning about it. And the reasoning comes by actually putting in a kind of database and a kind of algorithms. What are the rules for understanding either the face that we just looked at, or to understand the phonemes, or understand the music? So what are the types of representation, the families of algorithms that are used? Right. I have down here an example, the representation of an animal classification system using a tree structure. So you know what a tree structure would be. All animals, all mammals, all birds, things like that. Mm-hmm. And then it goes off in branches. Well, that's essentially what was done early in AI, or a tic-tac-toe system. Okay, and the third big idea, which is probably the biggest, is learning. What we already did is perception. The systems can now understand us. Can it improve on what's understanding? Can it look and notice that your behavior is in a certain way such that it can learn from your behavior and predict what you're going to do next, or say something more about your behavior than your behavior shows in terms of just vision, perception. So for this we need neural networks, data sets, and machine learning. And in this, let me just to give you a definition, machine learning is a field of AI, which we saw before, for understanding and building methods that enable machines to learn. That is, they come out and have improved performance. They don't just say, this is a bird that's moving east, for instance, or this is a bird moving south. This is a picture. Let me go to, yeah, it's a good picture. So this is a very deep learning neural networks. For instance, we would input many pictures of George Washington. We would have many hidden layers, which you don't understand yet probably, but each one would do one of the things that we just presented before. One would identify the edges. One would identify the combination of edges, which it says here. One would identify the features, one different layer. And then it would output and say, this is a picture of George Washington. All right, so it would start here, if you see the light and dark pixels, and then it would figure out where the edges are. It would say where the combination of edges are, etc. So this is when you add learning to what we already did, which was perception. And here we are doing it and showing that same person that we showed before and what it did with me, but showing the different neural networks. Each one is a neural network. So this is a neural network, let's say, for detecting the mouth. And this is a neural network. This guy is a neural network for detecting the eyes. Okay? And if you had a huge one, you could have a huge number of different neural networks, and each one would be assigned a different job. So here's this guy that we're still identifying. And at the end, we identify him, but all these convolutional neural networks are in between, and each one is assigned a different job. And the reason, this is an interesting point, the reason we don't understand, there's a part of AI that humans don't understand, and this is the part right here. It is that the system is feeding ones and zeros. Each neural network is feeding ones and zeros to other neural networks, and it can change and it can add, and you don't even know the strength of each of these neural networks. So the humans who invent these things can't, it's not like programming where you say send a 1 here, send a 0 here. It's that these things are sending values and we're not recording the values because it's too complex. So when they say people don't understand it, this is the part that is not understandable. The input you can understand, this thing on the left, and the output you can understand. But what goes on in the middle can be a variation of what you've programmed it to do. Again, the normal programming is you actually send the directions. In this case, you allow the convolutional neural networks to do something. And in the second talk today, we'll talk more about that. I don't know, with pictures or whatever. Okay, so here's, just to go over it, his face again, and all the neural networks. Real-time face detection by a deep neural network. Okay. academic. We won't go into them. So I think I won't try it. But this is a thing you could also use as a teachable machine where you train a classifier to look at a picture of a dog. This is a picture of a dog. And a picture of yourself. And after enough training, through those neural networks, it actually it will detect where is the dog and where's the person. So this is online machine learning that you can work with. Okay. And again, this is similar. Here we input. Yeah. Wow, how'd that? Okay. Okay, let me just finish here with a dog and the neural networks, I think. Okay. So the fourth big idea is natural interaction. So the first was perception, the second was representation, the third is learning, which is really big. The next one is natural interaction. Intelligent agents require many kinds of knowledge to interact naturally. And here's a child working with a robot that you can't tell, but it can speak, it can see her, it can talk to her. It's at MIT. And software can recognize emotions in humans because of their facial expression and can be labeled. It can label this child as happy or sad or angry. And it outperforms humans in some of these interactive tasks. So I think I won't go through this. We sort of opened it up before. The speech recognition, you can say, keep speaking, and it will keep trying to figure out what you said. And here it says, my parrot says hello, a parrot says, and it keeps saying what it thinks you're saying. Okay, the last idea, social impact, there's 3 components to that. And one of the biggest is ethics in AI, which is making decisions about people. And you all know about the bias in networks, which it's actually bias in databases. So if you had a database of all the people who got out of jail but might recommit a crime, if the database has mostly black people in it, then when it makes a decision, it's going to say, here's a black person, here's a white one. This one is going to commit another crime, and this one's not. So that's an example of bias, which we have to be very careful about. And transparency is that you can actually see how it's functioning and how the database is working. And that's the first component of social impact. The second is, what's the economic impact? So there's increased productivity because we have no idea what kind of jobs are going to come from this. So for instance, when electricity came, everyone said, oh my God, those guys who will run up the pole and shut off the gas or put on the gas, they're losing their jobs, we're losing jobs. But how many jobs did electricity create in the next few decades? And that's the position we're in now. We don't know what AI is going to do. And what kind of new services and reduction in some kind of jobs, like pattern matching and things like that. Okay. And the third component of social impact is living with these assistants and companions. Would you let your child travel unaccompanied with that robot driving the car, I think, etc. So there's a lot of impacts that we haven't investigated. I'm going to go on that. And this is actually interesting, but I think I'll leave it. This is just showing words, it can take a whole bunch of words in and identify them by gender, by culture, by social status, and put them in a big web. Okay, let me go. So now I'm going to move on. That was the first section, just an introduction to AI. This is research that we're doing on precision education, which is, okay, we've got a person, they're online, they're working on a math tutor, let's say. Can the system detect what the abilities of that person are, what the training is of that person, what the maybe mental condition of that person is, what the emotion of that person is, and then will it change the education for that person? In other words, instead of giving them the same 100 problems that every other system will give them, will it give them problems that are appropriate for that person, the right grade level, put out the right messages, etc. So we are using computer vision to support learning, and the students work online. This system, which I've already talked about, can look at the face, figure out if the student is confused or bored or excited, and look at whether that child is engaged or has emotional, or is emotional right now. So this is more of the same of what you and I were looking at before, but if you can detect that what the child is doing who's working at the system, detect what their mouth is doing, what their nose or eyebrows are doing? Can it make a statement about, oh, that person is unsure of what they're doing. Oh, that person is really excited and able to move on to the next level. And so we are working with people in computer vision to now do this for folks who are online, who are studying math at the 6th grade level. So develop computer vision software to detect students' engagement. The goals are to respond just in time, as opposed to getting a list of problems you're going to give them, and then it doesn't matter what they do, you're going to always give them that. But we want it to be just in time. If someone seems unhappy and inconsolable, that you change and teach them something else. And then provide teachers with the real-time information. It turns out teachers really love this. We have been giving them lists of the emotion. Here's the 30 people in your class. This one is really frustrated. This one is nervous. This one is actually moving on. This one is doing fine. And we give them this emotional, social information. They find it interesting because they've never had that before. And you can't do it. But
Hi, I have a question.
Sure.
When you're saying we right here, do you mean general fields of computer science, or are you saying specifically you here at UMass?
Yeah, I'm saying specifically UMass. So what I was talking, the first half is what the field is doing, but now I'm going on to what program and in
That's
computer
what I thought.
science.
I just wanted
Yeah, it's upstairs actually.
We're talking about like the collective societal.
No, we work in, both Dave and I work in computer science here at UMass. My office is upstairs, and this is the kind of work we're doing, yes. Yes, please, if there's any questions, that's fine. Feel free to ask. So as I said, teachers are getting really interested to see social, emotional information because they never get it. Oh, someone just told me they had a teacher, I forget the country, but I'll remember it soon, with 90 children in their class every day. Not in America, it was somewhere else. But I'll try. Okay, so here's what we do. This is it's actually a high schooler. And you see putting the hand on the top of the face, we have found out that means it's going to ask for a hint. I mean, what we do is use machine learning to figure out what it means, whether this child has attempted the problem, gave up on the problem, guessed, not read it, is going to solve with a hint. And the way we do it is we use machine learning to go back and see what 100 other children did when they put their hand in front. What does that mean? And when you tilt your head to the side or you turn around and stop looking, what does that mean? Here's the not looking part. And we're looking up. And we have been working with 6th graders, 7th graders, 8th graders, and college students, and community college students to see the difference. So we create deep neural networks, which you now understand, that recognizes the direction of the student's head as they use the tutor. And if they're not looking directly at the screen, they might be distracted, and the tutor can bring their attention back by saying something, or actually just flashing a light seems to work also. So we have used OpenFace, which is a huge database of people's faces. And it's available for free. It has 68 facial landmarks. So they go in the wild and they say, this person is angry, this person is frustrated, this person is in flow. And we use gaze direction, which is to understand, even if the head is normal, where's the eyeball at the moment? Where's the eye direction? And we use 18 facial units. When I showed you that picture of a woman smiling, all those other things on the top were what's called facial action units. And that's what's happening to the eyebrows, what's happening to the nose. And then the intensity of all these. And then we concatenate all that information for each student into a vector, onto a neural network of length 8,241, and pass it to a RNN, a neural network. Okay, so we're taking as much information as we can get and passing it. Yeah, go ahead.
Sorry, I don't think this is going to be a very scientific question. My understanding is that body language is more of a pseudoscience.
Oh, it's a pseudoscience.
To what degree do you use that kind of thing for this? How accurate is your results?
Right now, we are only on the face, but on the face and the gesture, the hands sometimes go in front. But if we were to move to body language, I bet we'd find a lot. But the thing is, we're looking at folks who are online. And if you're online, it's only your face. I mean, it's very rare that someone stands up and starts doing things, which they might. But right now, the field is not doing that, and we are not doing that upstairs.
Does it take into different cultural
we're working on, that's
Because a smile in one
Yeah.
culture means something different.
so we're just beginning to do that. And our team has folks from India and from Mexico, from Argentina, this group. And, we're trying to get as much culture into it. But you're right, everything has been egocentric to the United States because a lot more work is being done there.
Yeah, there's also a researcher who found out that her face, she was black,
Yeah.
a dark black woman, and her face wasn't recognized
Yes.
by the machine.
This is the AI bias
Yeah.
that we were talking about. That's really that. Okay, so again, we use gaze. Again, that's where the eyes are, and you see how we can detect the eyes, the eyebrow. We can actually see where the pupils are looking. Head pose, rotation, whether it's tilt, facial action units is what I showed you with that woman's face, and facial landmarks. Okay. A fully connected neural network was used to train those things. So what we have is, the first 100 or so students, and we figure out, so we have evidence of what they're actually working on, because they're working online on a math problem. They're getting it right or they're getting it wrong, or they're asking for hints. And then we can coordinate that with what our video showed us. And we need machine learning to coordinate it, to classify the two. And so once we have 100 students who have gone through it, the next 100 we can pretty much predict more quickly. And so we're starting to predict within 5 seconds of when they're working on a problem, how they're going to do on that problem based on their eyes, and a lot of training. Model was trained on a data set of 35,000 face images labeled with 68 face landmark points. Input of the model consists of facial landmarks, eyebrow, nose, etc. And this is what I said, there are existing databases that say this is angry and this is funny or this is happy. So this is AffectNet, is an existing available network, and you can see, I don't know what that expression is. This is angry for sure, and this is confused maybe.
Disgusted.
Yeah, and that one is haunted, etc. So there are a lot of databases out there. This is, of course, a facial one, but there are lots of ones. Oh, sorry about the Chinese there. Anyway, this is the math student system that we're using. It has a creature, a companion that is talking to you, and the statement that it makes is based on what we think you're doing. Are you going to ask for a hint? Are you going to quit? Are you frustrated? And it has available help. It will read the poem out loud to you. It will give you hints. It will replay your hints. And then it will take new problems, but it will also give you hints for it. Yes. So here's another problem. You see? So this is just a line drawing. Learning companion responds to student action with gestures. And this is one of the cases where if somebody's looking elsewhere and it comes up with a message, you were looking up. Do you want to join us? Do you want to come back? If you don't want to come back, it's okay. But we know you're looking up. So this is just trying to explain how we use that affect network that I just showed you with this crazy people. And we're looking at one person, and we're trying to use that network to help understand whether this person is disgusted, is angry, is happy. And the way we do it is to put here, these are all neural networks, so which is that we use the affect network. We use the, what I said, the features of the face, and then add these kind of in a row, all these neural networks and all those, and come out with a statement that you are about to ask for a hint, you're about to skip, or you're about to solve it on first. And then we keep refining these things to get them better. Student, okay, that's the neural network part of it. The other part of our system is that we ask the student every 5 problems or 8 minutes, are you frustrated now, are you confident? And in that sense, we can check back that we are making the right decision or the wrong. And we ask them to rate their affect on 5 points. So this is what it was. Please tell us how you're feeling. Are you interested? Are you not interested? And we do it with 5 different affects. So are you frustrated? Are you, etc. And then why is that? And we're taking this text and we parse this text to see if they are saying something about their emotion that we should know and put into the system. So in sum, we use facial and gesture recognition combined with self-reports to detect student emotion. and head position. So for the most part, the systems out there don't talk about emotion and social being. They just talk about whether a kid got it right or wrong, you know. So talking about Khan Academy and all the other ones that are out there. There's hundreds of problems and teachers go through them. Usually teachers have very little say in selecting them. You know, they can't choose to do parallelograms now and do triangles later. Pretty much the system's all set. But we're trying to look at this other thing. Yeah.
I have a colleague that I'm working with that is actually doing a similar type thing, but for autistic.
Oh, good.
And so I was kind of wondering how you are in a model, in these online types of things, obviously you're going to have a population that is neurodifferent, right?
Yes.
So how are you thinking about that in your model? So this is an example like where she's trying to sort of create that to address bias, but I do think that there are some particular things.
Absolutely.
Yeah, so what are you guys thinking about that?
We have not been working with autistic populations yet, but I do know of a lot of people who are doing that. Yeah, I mean, you take this body of work and you just keep moving it on to the next level. Just find out what that population looks like. And with machine learning, all we need is lots of examples, but there aren't a lot of examples of.
Or you have to unlearn it to get it to learn.
Yeah, but I'm saying you need a certain number. Machine learning takes tens of thousands of data points. So if you have only 10 autistic children, it's going to take a while to build up these databases. But absolutely, I'm pretty sure it can be done. Okay, so that particular model you were looking at is we use a synthetic database sometimes. I told you we add these strange pictures of emotion of 122,000 images that are labeled with head poses and facial landmarks to infer when the head pose changes. So we're looking at the yaw, the pitch, and the roll of using
This is still the open face 2.0, it's not the math,
Well, this is old, yeah. So yes, we moved
but it's
on.
related to the open face 2.0 and not the math tutor.
Oh, no, so that affect tutor that you're talking about is what we're using to inflows to augment our tutor, because our tutor just talks to, whatever, 30 or 40 children in every study. But we use the bigger one, then we put the two together essentially. Yeah. Because we don't have enough data.
Fake data.
Yeah. That's what I say, synthetic data structure.
Could you just for non-comp sci people, could you just take 1 minute? I think it's contextually really important to understand that we've been able to arrive at the age of AI where we are now because we had everything. There was so much data.
Oh, absolutely.
Right, and the comp sci system. So when I was working on systems 20 years ago and the early web systems, we were all like, we don't have we don't have a massive digitization or other types of information, but now we have that, so we can be in the age of AI, like with some sort of affect that is really sort of transforming. That's why it's coalescing at this moment, because there's enough data around to make it possible. When I say data, I'm writ large, like
and specialized data.
And specialized data, exactly.
Visual data and face data. Okay. Yeah, go ahead.
I'm just curious, how often are you testing the students? Is it like once a month? Is it once a quarter?
It depends on the program, but we have been in the classroom every week this year, the 6th, 7th, and 8th grade in Massachusetts. So we have about 20 teachers in Massachusetts who are using the system at 1 day a week, the system I showed you, and collecting data from them. Wow. So, and then there are other studies, that go just for 3 or 4 weeks, because we try like that up and down one with just 3 or 4 weeks. But in terms of learning, we're looking at children's learning of mathematics using the system starting in September and they just ended in June, and they ended with MCAS. You know what MCAS is? So it's a state standard test. And so we're watching the folks who used the system and the folks who didn't, and looking at the Massachusetts cumulative assessment system to see how if learning changed. Yeah.
What sort of reaction have you had from the parents of these kids? Are there a lot, or is it a mixed bag? Or I'm imagining there must be some who are very enthusiastic and some who have absolutely refused to let their kids.
The thing is, we have to get the signature and approval,
right?
And we do it at the beginning of the year, and the parents don't know much about it. So we have not done what you're asking, which is to find out at the end of the year whether they thought it was an invasion or anything, and we actually don't explain it to them. So We are negligent there. But we do get their permission. I mean, we absolutely get assigned.
Permission to share their faces on this presentation, for example. Like, they have to sign away.
The
They
one
have
or
to say
two
it.
that we showed, yeah, but
Yeah.
it did sign away. I didn't sign away. I mean, they gave
You know,
permission.
like,
Yeah,
sign
but they-
permission to share that.
But we don't share any of the others that do not give permission, right? Yeah.
Are there any parents that say no at the outset, though? At the beginning
Yeah,
the
of
year?
course. And what happens is the math teacher is asked to include them in the classroom. They just don't use the system, or if they use the system, we can't use the data. So it's
Yeah.
either they don't let them use the system or we don't use the data. So yes, we go through at the beginning of each year, we have to go through all the parents and get permission. And the teachers have to also get permission.
Is it many, though?
Many that don't do it?
Right.
No, it's few.
Most are buying.
Yeah, I mean, what we're asked, we just say, you know, this is an experimental system. We're going to use the data, but we're going to amalgamate the data. Nobody's child's name is ever put on here. And they seem to accept that, yeah.
The microphone is not talking to the speakers anymore. Go check the connection.
Tell me what you want.
I do think that, at least in the course that I teach about AI and society, I've kind of broadened it a lot to move beyond ethics.
Yeah.
Because it's really a lot more, it's way beyond ethics. It's really about governance.
Yeah.
So we get into because ethics means something like, we all have an internal thing and we may have a philosophical way in which we proceed with how we want to do this. But if we don't have governance, you can have all the ethics in the world that you want, right? So in AI, I specifically think for this, it's really governance oversight is where we're running away.
I'm saying the same thing. We need regulation on this.
Yes.
And we really need it. The people in the field know we need it. You know, people working in AI say, this is ridiculous. It's unregulated. You don't have transportation unregulated. You don't have cars going in every direction. We need to regulate this thing. But we so far, you know, it may be an information issue that the legislators don't know enough about AI to legislate the thing. But I agree, totally. Okay, let me just finish because we have to go on. Response to student emotion. So they use the system. We provide 3 categories of response. I guess I'm not showing it here. Students who believe that so growth mindset, I don't know if you've all heard of that. We love it. Some students say that intelligence can be increased. It leads to, so the little character says, do you know that when we learn something new, our brain actually changes? It forms new connections inside to help us, new neural networks, to help us solve problems in the future. Pretty amazing, huh? So we put out these growth mindset messages to help them. And DeMello is another researcher in the field, found successful results when they use that message.
What gender differences? What did that? I don't understand that.
Did I say gender?
It said led to gender differences.
I don't know what I said gender.
The middle bullet there.
Messages led to gender.
Led to, okay, growth mindset. Yeah, and I don't remember what it was. Led to gender differences, and so I do have a data sheet of that. And I forget right now, but I'll go look. So we measure females and males, and the question is who accepts that message better. And we do have records. But these are some of the other kinds of messages. That's right. So this guy is looking kind of confused. I often get discouraged. This is when somebody didn't do it right, when struggling with a math problem. Although I think more important than getting the problem right is putting in the effort and keeping in mind the fact that we can all be good at math if we try. And you know, when we learn, we should have seen that one. So we put this kind of messages put together by putting these little pieces together. Measure the cognitive and affective attributes, offer appropriate responses, and then measure the impact. So let me see if I can get to, this one's interesting. I want to show you this. This is another graph that we just came out with this day. These down here are the problems. You know, they're all 6th grade problems. It says 6, and it's actually ratio and rates and 7th grade problems. The question is, how does the machine select the problems? And the answer is, it actually is measuring the student's mastery. You see the red line? So he got that one right, he didn't get that, then he got that, then he didn't get that, blah, blah, blah. Then the system starts changing difficulty, that's black. It keeps the difficulty at the same level, and then all of a sudden, if the kid is doing well, my God, then it increases the difficulty. So it goes on, as you see, from 6th grade problems to 7th grade problems. And then the kid doesn't do so well there, so it just goes back down. So in other words, the system is not just putting out all these problems and you solve them. It is monitoring that child and figuring out what's the best problem for that kid at this moment. It's unbelievable. And then how many videos, they don't look at a lot of videos, how many attempts did they make? And we do track all this for. So as you can see, this involved a large number of variables, and that's the thing that's important. And so when a math teacher is working with a child, there are all these variables they keep in their mind, but if it's 30 kids, no. But if it's a small group of kids, you say, oh, he really needs that. Oh, he's really flowing. Why don't you move him on? She needs that right now. And a good teacher is doing all this, and what we're seeing is a large number of variables. So we use computer vision and machine learning, but the good human tutors using their instinct and their experience for 20 years, etc. And the problem is given a set of candidate difficulty levels, which is what we have. So all of our problems are organized by how much pre-knowledge you need, how much difficulty each problem has. And we run a model to obtain what this child needs. And that level yields a positive problem outcome. So we figure out, make an estimate of how the child will perform on each problem. So suppose a student just solved a problem in a learning session. We have the students learning log data, how well the student has mastered the exercise so far, and the difficulty level. And this is just one study. It's 61 students. All students completed a pre-test and a post-test. And we have an event log, which is saying how many mistakes they made, etc. And we recorded 3 classes over 4 days, etc. So there's, and then, for instance, we give messages that look like empathy. Don't you sometimes get frustrated? When we give growth mindset, did you know that when we practice your skills, your brain grows? And we do success failure. Very good, very right. Turns out when you say very good or very bad, they turn off. Most of the children hate that. They get angry with it. They show more frustration because they don't want to hear it. I mean, they've heard it before and they don't get much from it. When they get the empathy and the growth mindset, they respond better. So with exposure to empathy messages, students exhibited higher levels of interest, because we're always asking them about interest, and higher value. With growth mindset, students got more problems correct on their first attempt, yet they say they value math less, and we don't quite understand that. With the successful and failure, yes, you did it, no, you didn't. Students were less learning oriented and more confused by it. They say they're more confused, and less learning oriented means they were not interested in learning, they're interested in getting it right to show off. We asked them that question. So these are some of the results. So we are correlating when we give these empathy messages, when we give the growth mindset messages, when we give the success failure messages, and we ask the student, how's your interest, are you confused, etc. And you'll see that that goes down. But if you say empathy, they get more interested. If you give them empathy messages and you give them math value, they say they have increased math value when you give them empathy, and they have increased confusion when you give them a success failure message, and they say that they have less learning. Okay, so let me just move on, and I'm almost done. So I say the Industrial Revolution made humans more machine-like. Humans have to do more repetitive, more physical work. The thought is, shouldn't AI make humans more human? Could it possibly, reduce the amount of repetition that a human has to do and allow humans to deal with more creative things? Eliminate the low-level pattern matching. And I'm thinking library science, what happened? Library science should enable humans to be more human, to go beyond the content and get more human relationships. I'm going to get a drink of water. So the question is, can humans focus more on the context and more on the conditions around what's going on? And remaining questions that I did not answer. Do we trust AI? I think you need to know a lot about it and keep on it, on top of it. Do we trust large language models? Same kind of answer. What is critical evaluation of AI for librarians? How do we use large language models for, say, something like medicine? So the MedLib articles are great, but again, the system is not understanding what they're saying. How do we augment human activities with AI to deliver better and more human care? And we need more research on AI and human factors to bring AI into workflow. Okay. So, do any questions? I mean, you had great questions. Yeah.
What level of practical application are we at for commercial, for libraries, for any sort of non-academia?
And you guys don't know the answer to that?
I do. I would say in library science, it's already pretty high.
Yeah, tell me.
Our vendors have been using it. I mean, I don't know, we just installed the
Do you also work
X-Libris.
here at UMass?
No. I work at Colby, but we just installed the X-Libris system, which is the Alma Primo, which most most elite libraries, I should say, right, are adopting it. And they've actually used a lot of machine learning to train on how to get better results and their relevance. So you can already see the pattern matching is better, and so they're harvesting all that information. I would say for our vendors, it's already a harvesting of information. I would say in regards to the document portion, I think for archives, it has actually a lot of potential benefits. However, what is really, I think, very difficult for libraries is you have to digitize these, and then you have to do some amount of training and labeling on them in order to do a good interpretation, right? And so because we haven't created many what I would call base models, I think some of those more rich things that could happen for us in regards to tagging, discovery, etc. As a group, we really haven't started working on that collectively to sort of leverage. So our vendors are very far ahead of us, our unique collections that we may be interested in leveraging and increasing discoverability and connectivity, right? So,
But all these vendors, I mean, if you don't have, and no one's sitting down and doing labeling, do these vendors really have something to sell, or are they just saying?
well, no, I'm meaning like if you have, somebody's papers, right? Or if you have unique images or artifacts, those are things that vendors wouldn't have had access to digitize, right? And so because we're sitting on a lot of ephemera and documents that actually have important cultural relevance, like getting them set to be ingested into an AI system is going to take a lot of time. And we also, I wouldn't say, have decided on effective nomenclatures. We do have like Dublin Core, which is super helpful, but I think in general there has to be sort of a lot of discussion about what this looks like. And I would also say that libraries are pretty careful about entering into contested technologies.
Yeah, but what are the vendors selling you? That's what I'm saying.
They're selling indices, I would argue. So what a big database, right? Like, I don't know what database you use, but like, if someone was using Scopus, right? What the vendor there is selling us is efficacy and indexing. They have amassed all of it. They also, what they're selling us is the ability to take work to transfer information as it moves through different formats and cycles. So a lot of the stuff maybe was paper that then got put onto microfiche that then got put right. And so they're actually moving it through the process so that it's able to continue to have a life.
When you buy it, you're getting the actual documents with labels on them?
They've done all that and they've digitized it and everything. So yes.
And we're not buying it, we're getting access.
Yeah, we're getting access.
We're paying for time limited access.
Got it, okay.
Yeah.
Cool, great. Any other questions?
Well, to go with that example, National Library of Medicine has leaned hard into machine learning for indexing. So if anybody remembers that, like even a couple of years ago, it was completely normal to say that there was like a 6-month time lag in mesh terms being attached to an article.
Yes.
According to the most recent NLM update, that has been cut to like 2 weeks.
Yeah.
Because it is being done almost exclusively by these like machine learning algorithms, and then a human is only having to do like, let's say 20% of spot checking. So because there used to be that huge mismatch between the capacity of the human indexers versus like how much was being published at any given moment in time, that they have leveraged that.
Yeah, that's a good use.
Yeah, I would also say, just as a last thing for you is that like in something where you have an indice on it and it is a format that is repetitive. Say, for example, I'm working on a project where we're using the Tabular and Pandas library to extract information off of PDFs. Super easy when the PDF has a consistent format, as you know, right? And so, but I would argue that the really good stuff in libraries, as far as documentation, has no consistent format. So the labor involved becomes really heavy lifting. And there's, you know, and also in our own discipline, we've gotten a little like strayed away from the comp sci people. And so I'm hoping there'll be more of a rich union that will happen there.
Yeah.
How can we fix bias?
Yeah,
Because there's all that information out there already. We're not going to be able to take it back. Is it just add more balanced information?
But we have to revise the databases that are already biased.
Exactly.
I mean, how were they created? And we have to redo them.
And how is it librarians can do? Should we be refusing biased databases?
Oh, absolutely.
Should we be demanding the
And the question-
vendors fix?
Yes, I mean, if you find errors. So the question is, how would you know that there are errors in the database?
Yeah.
But you could be the arbitrators of that easily, because you're the ones who have more handle on information than anyone else does. Yeah, David.
I would just answer that question. The one thing you should consistently ask is, how has this been audited? How is it evaluating the bias? If you ask that question enough times, if enough people ask that question, they'll start doing it. They'll do it badly at first, but then they'll probably eventually. This has been there's really no way to tell, except if you do a fairly comprehensive audit or evaluation of the bias, you know, involving some model that comes out of analyzing a particular data set. There's lots of different ways that bias can creep in.
It's a good question, though, but it's good if you guys would keep on it. To keep the rest of us honest. Okay. Thank you all very much.